Hello everyone and welcome back to the channel. In the world of distributed systems where your application runs across many servers and services, a critical question always arises. How do you know if a specific component is still alive and functioning correctly? Servers can crash, network can partition, services can freeze. This is where heartbeats come in, a fundamental mechanism for health monitoring that's absolutely vital for building reliable and fault-tolerant systems. In system design interviews, discussing heartbeats demonstrates a practical understanding of operational robustness. Today we are diving into their crucial role. Okay, let's first talk about the problem. Okay, the core problem heartbeats address is the failure detection in distributed environments. So it's surprisingly hard to distinguish truly dead component from one that's just temporarily slow, or perhaps isolate by network issue. If a server stops responding, you need to know quickly so you can first remove it from load balancer rotations, trigger a failover to replica, maybe reassign any tasks it was supposed to be doing. Without a reliable way to detect these failures, your system risks sending traffic to dead nodes, leading to timeouts, errors, and degraded user experience. Heartbeats will provide a proactive regular signal of liveness to solve this exact problem. So what is a heartbeat? A heartbeat is a periodic small message sent by a system component, typically a server, maybe a service instance or a node in a cluster, to another component called the monitor or leader to indicate that it is alive, responsive, and functioning. Okay, so think of it like a human pulse, or a continuous "I'm alive" signal. Okay, so how does it work? So maybe we have here a client, we have here a server, or let's call this a sender. So we have a sender. Okay, let's just give it a sender, a receiver, because it's easier. We have here a sender and we have here a receiver. Okay, the sender here, it's a component like web server, maybe it could be a database, a replica, something like that. A sender is configured to send a small heartbeat messages. This message is usually just a simple packet, perhaps containing a sender's ID and timestamps, sent at a regular heartbeat intervals, maybe every 5 seconds. The message is sent to a receiver or a monitor. This monitor could be centralized health checking service, or maybe it could be a cluster leader, or even all other peer nodes in a decentralized system. So we have here the sender and the receiver, and every 5 seconds, the sender will send a heartbeat to the receiver. And let's assume that we have 10 seconds, and in 10 seconds, when the sender doesn't send anything to the receiver will announce the server as dead or as failed. So the receiver here, which is the monitor continuously listens to 4 heartbeats from all registered senders. It doesn't hear from only one sender, and it maintains a timestamps or a tracks of time of last received heartbeats. So in terms of failure detection, if a monitor does not receive heartbeat from a particular sender within a predefined timeout, let's say maybe like 2 or 3 times, for example, for our example could be like 2, so 10 seconds or 15 seconds, it will declare the sender dead, unhealthy, or unresponsive. So once the component, which is this sender, has been declared as dead, there are some automated actions will be triggered immediately. 1, its IP address is removed from the load balancer's pool. Number 2, a failover process might be initiated. Number 3, pending tasks assigned to that node might be reassigned. And number 4, alerts are sent to operations teams to investigate in this case. Okay, but why this matter? So heartbeats are fundamental for building robust system design, robust distributed systems. And it is beneficial specifically in rapid failure detection. Like, this is the primary purpose, I would say. They allow you to quickly identify and react to crashed or unresponsive nodes or services, minimizing downtime. Number 2, high availability. By enabling automated failover and removing unhealthy nodes from active service, heartbeats are crucial for ensuring continuous service and high availability of your application. Number 3, fault tolerance. They are a core mechanism for building systems that can gracefully handle individual component failures without collapsing entirely. Next, number 4, resource management. They ensure that valuable network traffic and processing tasks are not sent to dead or unresponsive nodes, optimizing resource utilization. And number 5, which is simplicity. The concept of heartbeat is relatively simple compared to complex distributed consensus algorithms, making it a good first line of defense for liveness. And lastly, something about interview focus. Bringing up heartbeats will demonstrate an awareness of the operational challenges of distributed systems and a commitment to building reliable self-healing architectural systems. Okay, there are some key consideration and trade-offs. Why you always do that? Yep. Okay, there are some key considerations and trade-offs while designing a heartbeat. Number 1, heartbeat intervals versus timeout thresholds. So the first thing we want to think about too frequent an interval. So if we have a too frequent an interval, this might leads to high network traffic and CPU overhead on both sender and monitor. If we have too infrequent an interval, this will cause a slower failure detection because we will not doing it frequently or as we should do. Number 3, too short or timeout, like can lead to false positives, like where a perfectly healthy node is mistakenly declared dead due to a transient network glitch or brief spike in load causing a miss heartbeat. This results in unnecessary failover or flapping. Maybe you can have some sort of false positive. As we said before, heartbeats alone cannot perfectly distinguish a truly dead node from one that's simply experiencing a temporary network partition. For very strong consistency and state management, heartbeats are often combined with more sophisticated distributed consensus algorithms like Paxos or Raft. And number 3, overhead. Despite being small, consistent heartbeat traffic adds to network load and consumes some sort of CPU cycles. Okay, so how to discuss it in system design interviews. System design interviews, when discussing fault tolerance, high availability, or handle server failures, you need to bring up heartbeats, explaining how you would detect failures using heartbeat intervals and a timeout thresholds. You need to discuss the trade-off between detection speed and false positives. It shows a particular and a mature approach to operational robustness. So that's it for this video, and see you in the future, guys.